I need to say, though, that I am pinch hitting. We originally intended to have Phil McAllister, who is the program exec for the Commercial Crew Program up in Washington, be here. And even though he probably got one of those 1 a.m. phone calls telling him to come to work this morning, he couldn't fly out here. So I am pinch hitting for him on this panel. And we've assembled, I think, a really, really great panel to talk about when the government is ready to buy. What are the risks? What are the rewards? Each of the panel members is going to be spending about 3 or 4 minutes talking about, or maybe a minute or two more. I can't see the clock. That's a good thing. On risk and reward as they see it from their standpoint in their particular place in this industry as they build commercial crew or commercial cargo resupply vehicles. And then we'll have some questions that the panel's agreed to discuss for a few minutes, and then we'll take questions from the audience. And I will do my best Phil McAllister impression, but we'll see how we last. So the distinguished panel that we have here includes John Mulholland, and I've known John for more than a couple of years. John's a native son of the land of enchantment, born and raised, went to high school and college here in Las Cruces, came to work at White Sands Test Facility. As we heard yesterday, that great place where you can blow things up and do other interesting experiments. Went to Houston to support the Space Shuttle Orbiter project. Worked for many years in the Space Shuttle Orbiter project, ensuring safe flight. Went to work for the Boeing company as the program manager for their support for the Space Shuttle Orbiter project, and helped us through numerous difficulties. We had many interesting days trying to make sure that we were safe and good to go fly, and John led the team that did all that great work for us. And now he is the program manager for Boeing Civil Space Programs, which principally, not totally, but principally include the CST-100 commercial capsule, which is being prepared for flight as soon as we can get it ready, as soon as the government will continue the funding. So we'll let John talk in just a minute. I want to go ahead and introduce the other panel members, and Mike Pinkston is next on the list. Mike is Orbital Senior Vice President and Program Director for the Antares program, responsible for the development, manufacturing, and flight operations for the Antares space vehicle. Previously, Mike was the Senior Vice President and Program Director of Orbital's Orion-based targets, not the Orion that we talk about in names, but Orion-based targets where the company's medium-range ballistic missile and air-launched intermediate-range ballistic missile targets program. He also served as Senior Vice President, Program Director for the Orbital Boost Vehicle, Ground-Based Mid-Course Defense Missile Interceptor Program. Worked on the Minotaur 1 and Minotaur 2 launch vehicles, 25 years of engineering and program management experience. And I just want to say a word about the Antares, of course, a very complex and highly capable new launch vehicle that came online earlier this year that is not only the first new launch vehicle, I think, that's been developed in the last couple of years, but also a new launch site. I mean, the Wallops Flight Facility had only launched solid rocket boosters before, and now they have liquid capability there due to Orbital and its work, and Mike has directed all that, and it's just outstanding. Next to him is Lee Archambault. We all know him as Brew. Brew was, we worked together many years in mission control. He's kept calm, I think, for me. When back in the day, Brew got his engineering degree from the University of Illinois Champaign-Urbana, came to work for Uncle Sam in the United States Air Force, flies, speaking of flying, something up here, has flown 30 different aircraft, flew F-111s here at Cannon Air Force Base, flew F-117s, 22 combat missions, I think, in Desert Storm, Distinguished Flying Cross, test pilot school at Edwards Air Force Base, came to work for NASA in the astronaut program, and flew twice on the space shuttle, and recently retired from NASA. and is now test pilot and I think general manager in charge over at Sierra Nevada on the Dream Chaser program. And I hope you're leaving from here to go to Mojave and start flying that guy real quick. And finally, last but not least, Andy Aldrin. Andy brings a different background, which I think this business really needs. He got degrees in political science, Master Business Administration, and PhD in political science from University of California. And he wrote his thesis, PhD thesis, on the foundation of the Soviet space program, and an innovative time in that very bureaucratic central planning kind of government where they had to innovate a totally new way of doing business, and were very successful, and I think there are lessons that we could apply there. He has come, I won't read his whole career. He has done a number of very interesting things, but he came to work for Boeing, worked on the Delta launch vehicles, and now he is the Director of Business Development for United Launch Alliance and their human spaceflight organization, where he gets to work on not only the Delta IV launch that's going to test out the Orion crew vehicle here next year, but the Block 1 upper stage for the Space Launch System, the big rocket that's being developed to do deep space exploration. But more germane, I think, to what we're talking about right here, the Atlas V support for both the Dream Chaser and the CST-100. So we have got a great panel, and I'm going to kick this off and let John Mulholland will go right down the line. I think we agreed to no charts, guys. So,
I've got charts.
Oh, you got charts.
I've got
Okay.
charts
Well,
and
there's
videos.
always somebody that's going to break the mold. But we'll start with
I didn't make the telecast.
we'll start with John Mulholland, and you can give us your take on risk and reward in this business.
Yeah, absolutely. Thank you very much. And Pat, thank you very much for another great conference. The direction from Pat was no charts, and that we had 4 minutes to totally outline all of the risks and potential rewards in commercial spaceflight. So as a backdrop to that, I think it really is important to outline our program path and some of the objectives of this round. As most of you know, the focus of this round is maturing the design to a critical design review point. And so our total focus of this phase is making sure you maintain your performance to plan. One of the huge risks in any development program is traveled work. And as you move work because you miss your performance to plan targets into the verification and validation stage, you really put your design at risk from a schedule and technical standpoint. So a lot of focus on making sure we get to a robust CDR and maintain that performance to plan. Our approach has been to make sure we have a highly integrated analytical and test focus as we move through. We have a lot of development tests that have targeted objectives to make sure that your design is maturing and that you will be able to meet all of your requirements. As an example, just a couple months ago, we were actually running simultaneous wind tunnel tests at 2 different facilities in different parts of the country. And this week, we have kicked off another round of launch abort engine tests. We've got 5 more engines that are going into development test in one desert, and we're running a number of single parachute drops to validate the parachute design to its expected loads at another desert. So just a highly integrated, focused plan to make sure we get to a CDR. You know, the other approach that we have is to make sure that wherever possible, we use hardware that's flight proven or has flight lineage. Again, just to drive down that technical risk. And moving into the risks phase, hopefully a lot of you were able to hear John's talk yesterday. But one of the quotes that he had up was, "This is a problem-rich environment." Different context, but that comment really hit home. Within any development program, you are always going to be faced with development risks, and it just really is important that you're able to beat those down and get them behind you and maturing your design on schedule. And that, I think, is one of the big risks for us obviously in this complex development, but it's typical of any development program. And then I think the second risk is uncertainty into exactly what the government or the customer wants to buy. You have, I think, a mixture of three very different companies, very different in their maturity and their life cycle and their approach. And you have three very different designs that are being offered. And typically in a government program or a government-led program, they come out with a very detailed performance work statement, and everybody knows exactly what they want to buy. In this case, the government, by design, has been much more flexible. They're trying to encourage innovative and new approaches. And so every company has now outlined their approach that they think will be the most successful. But with that comes the risk that you might be maturing your design in an area that might not be the focus of what the government wants to buy. So I think that is a very big risk. And I'll give you just two examples. And I talked a little bit about our focus on making sure we really get to a robust CDR. And in one of the talks yesterday, one of the comments was made that another company is getting to approximately a CDR. Totally different focus on that design maturation, but the importance of either approach is unknown. And the second one that I think is really important from a risk standpoint, and since Andy's up here, I'll just tee him up for it. Two of the companies have decided to use an Atlas V launch vehicle as their baseline approach for the commercial crew. A lot of work went into that selection and the evaluation of that. And our decision was that with the Atlas V, with 30 missions under their belt, 100% mission success ratio, so a very high mission assurance, that was the right approach for us. SpaceX, as you heard yesterday and as you know, is using the Falcon 9 version 1.1. A totally new launch vehicle, one successful mission, but just at a different stage in their life cycle. And from an advertised standpoint, a significantly different price point. And so what is the right approach? Do you go to potentially a higher price point with really assured access? Or do you take the approach of maybe hitting a different price point with more technical or schedule risk associated with that? Just very difficult, and not knowing with certainty what is the most important criteria drives some risk, I think, in the approach. From an outsider perspective, it's just got to be a lot of fun to watch, right? The different approaches, the different tactics. As an insider, not so much. From a reward standpoint, I think for us it's very simple. The Boeing company has been integrally involved in every domestic human spaceflight program. It's something that as a company and for me personally, we're very emotionally attached to. And it's a market segment that we're committed to maintain and foster. And so I think that's very simply our story. And thank you.
Thank you, John. Mike, we'll let you go ahead and
Okay.
Tell us a little bit about Antares.
Yeah, first I'll apologize for not getting the message about charts. I had to miss the.
We're going to blame that on Phil, by the way.
Well, and I missed the telecon. We were out actually launching a rocket, and that's primarily what I want to talk to you about. So if we could bring up my my charts, you can go to the next chart. So on September 18th, we launched the second Antares rocket carrying the first operational Cygnus spacecraft, put it in a precise orbit, and about 11 days later, Cygnus successfully rendezvoused and berthed with the International Space Station. It's a proud achievement for Orbital and I think the industry in general. We've got a little bit of work to do. Next week we will deberth on the 22nd, and then Cygnus will re-enter on the 23rd, carrying a cargo of trash into the atmosphere. But I think it's relatively safe to suggest that we're very close to the end of the development phase of Orbital's cargo resupply capability. And I think in general, it's also safe to say that it was the most significant challenge our company has ever undertaken. And over the course of the development effort, we developed a brand new mid-class space launch vehicle called Antares. We developed a new launch pad with the help of the state of Virginia and the Mid-Atlantic Regional Spaceport, including a new liquid fueling facility to support the Antares launch vehicle. We also developed a Cygnus spacecraft that has all of the appropriate complexities necessary to successfully rendezvous and berth with the space station. And all of those, in and of themselves are loaded with unique challenges, and that, bore itself out in the way of, repeated schedule delays and troubles and the like of that. But, we got through all that, and, at the risk of, not naming everyone that had a hand in getting us where we were, I do want to make sure to point out the partnership with NASA as a key element in our ability to get there. NASA brought not only an investment, they shared the risk, but they also brought specific expertise and resources to the table that allowed us to get where we needed to go. So, with that, I do want to show you a quick video. I will mention before I get to that, we're squarely focused now on our next mission, the first mission under the Commercial Resupply Services contract. We're targeting the middle of December. This is a tall order and a quick turnaround from a demonstration mission in September, but we're optimistic we're going to get there, and that'll be that mission will carry about 1,300 kilograms of cargo to the International Space Station, and will represent the largest commercial delivery to date. So we'll be awful proud of that, and not that anyone thinks that's all that Orbital's got going on. We've also had several other significant launches over the course of 2013, including the inaugural launch of our Minotaur 5, which carried the LADI mission put it in a trajectory to the moon. So that was a big event for us as well, along with several others. So if you'll go to the next chart, we'll show you a quick video, kind of a compilation of the mission. Here it comes. A little music to go with it. So a few views of our final processing facility, the horizontal integration facility, where we process the Antares rocket, the final cargo load on the Cygnus spacecraft as we're getting it ready to button up, put the fairing on. This is actually happening a couple of days before rollout. We roll the rocket out about 5 days before launch, erected on the launch pad. We're actually working to get that timeline down significantly on future missions and be able to do it in a day. Then you see the launch of the Antares. It was actually a really nice day to fly. The rocket cam video shows a good view of the mid-Atlantic coast as we depart on our way to orbit. Getting close to main engine cutoff, and then separation of the first stage. All of that went extremely well. Then you'll see the fairing separation, exposing the Cygnus spacecraft, and then our second stage burn, putting Cygnus in orbit. And we separate the Cygnus, and then we immediately start a collision avoidance maneuver to get out of its way. And then Cygnus is in orbit. And we'll show you just a few shots of Cygnus approaching the space station from below. And then here's the little bit of a time lapse showing the approach, the final approach, getting ready to be grappled by the robotic arm on the station. That's our destination from below. And then some video of the robotic arm approaching the Cygnus spacecraft. This is really, I think, pretty neat. You see it closing in, and it'll eventually grab it. probably a little more video than we needed in this. Then a handful of shots as they move the Cygnus closer to the space station, and it'll eventually be berthed. And then once on board, the crew opens the hatch and we'll begin to unload the cargo that we brought. The demonstration mission had about 700 kilograms of cargo on board. A relatively small load for what we expect to be doing in the future. And then, for those that don't know, we dedicated the mission to the memory of G. David Lowe, a former NASA astronaut and orbital exec who left us way too soon. And I think that's about it. I've got, a couple of photos that'll you follow in the charts behind. But I think, the main point I want to make is, we've achieved some, obviously a big milestone with that mission. Our focus now is on, really getting into an operational rhythm and having, reliable access to, for cargo to services to the space station when NASA needs it. And with that, thanks.
Thanks. Thank you very much. And Brew, we're going to hand it over to you. The topic was risk and reward. How do you see those for Sierra Nevada shaping up in the near future?
Thanks, Wayne. And I'm like Wayne mentioned before, he's pinch hitting. I'm pinch hitting also. Our corporate vice president, Mark Sarangelo, sends his regrets and sent his second stringer out here to sit in for him. But it's great to be here today, Wayne. Always enjoy talking with you. I have nothing but the highest respect for what you've done with our space shuttle program and our space program. John, nice seeing you again. John and I go back a long way, more on a personal note. His son and my son used to play basketball together. I think John was our coach one summer. And so great to see John again, except not on the basketball court. Mike, haven't met before, but congratulations to you and your company for a fantastic success. We're very excited. Yeah. And Andy, nice to meet you. I haven't met you before, but of course our company is very excited about our collaboration with your company as well. We hope to do a lot of business with you in the future. So I'm here today to talk, actually to share with you a little bit about what we're doing at Sierra Nevada. As Wayne mentioned, we're hoping to get back to Mojave real soon now that the government shutdown is over. And so I brought a fighter pilot slideshow, which is called a movie. I think Mark Polanski can relate to that. We got two of them. I think the total time goes a little bit more than 4 or 5 minutes, but we'll play them. We can cut them off whenever we have to, just to keep the show on moving. So, Steve, can you play the first one?
Sierra Nevada Corporation's Dream Chaser flight vehicle rolled through a series of ground tests at NASA's Dryden Flight Research Center.
And you are go to arm co-separation and change mode ready. 40 miles per hour.
Tow arm, change mode ready.
After arriving at the California facility in May, workers unwrapped the test spacecraft and attached its wings and tail. Then a pickup truck pulled the winged vehicle at intervals of 10, 20, 40, and 60 miles per hour on concrete runways to help assess its braking and landing systems.
Ready, release.
These tests are preparing company engineers for upcoming captive carry and free flight tests at Dryden. Sierra Nevada Corporation is one of 3 American companies working with NASA's Commercial Crew Program to develop safe and affordable crew transportation systems to low Earth orbit and the International Space Station.
So that was about 90 seconds worth of video showing what we were doing this summer. Our Dream Chaser showed up out at Dryden in the May time frame. We did about 90 days worth of ground tests that included those taxi tests you just saw. And we've also had a captive carry test very recently. And so we're very, very close to our first drop. And we expect that we would have had that drop by now had the government shutdown not occurred. But now that it's over with, we're going to try and spin that process up very, very soon. I've got one more video here that does indeed show you a little bit what that captive carry test was like. So if we can spin that one up, Steve, I'd appreciate it.
Yes, we can move the stairs to a different area.
see, we're going to be, captive carry was to do everything but drop the vehicle. We'll be dropping from a sky crane from about 12,000 feet MSL out at Edwards Air Force Base.
And thanks, Brew. This is really fun
Ready to cut it through?
photography, but
We can cut it.
We're
That's
gonna,
fine.
we need to
So you
get
have an
on so we
idea
can
about
answer
what the drop test is going to look like. We're basically going to drop from that same sky crane, and we're bringing our team back out to Dryden as we speak. So
Very
thank
good.
you. Thanks, Wayne.
Thanks,
We'll roll it.
Brew. And last, as on the panel up here, Andy is going to talk a little bit about the risk and reward that the United Launch Alliance is facing in this commercial human and cargo space arena.
Thanks, Wayne. So I actually did dial into one of the telecons, and one of the things that we talked about ULA bringing to this was a little bit of a historical perspective. And in looking back at launch over the years, it really occurred to me that there's almost an addictive sort of attraction to the launch industry. And I had suggested that, maybe we need to start up a chapter of Rocketeers Anonymous, and I think Janet is going to be hosting the first meeting of that. It's like moths being attracted to a flame. And, the last time we did this was sort of the turn of the decade. And I tell you, the flame burned brightly. There were going to be thousands of satellites orbited by Teledesic, Ellipso. And, those of us who lived through that, I think some of us still feel the singe on our wings. And today, the flame's burning again, but it's different. I think there's something fundamental, a couple of things that are fundamentally different about, if you will, carry this metaphor on to a little bit more ridiculous extent, just, the differences in the flame today. I mean, first of all, I think the flame in some ways is a little bit smaller than it was before. Back at the turn of the century, as I said, we were looking at launch rates for Boeing or Lockheed that were in excess of 20, maybe 40 launches a year. Okay, I don't think anybody really harbors that illusion. There isn't a dream of 840 Teledesic launches out there, So I think there are kind of more realistic market expectations today. I know this sounds crazy, particularly given everything that's going on in Washington. Maybe things are a little bit more stable today than they were, at least in terms of market expectations. And if you look at the market that's out there today, it's a significant market. So between crew and cargo, you might be looking at 8 launches a year. That's probably 40% of the total government market. It's a big deal, but people are basing their business plans on that kind of a market assessment. And so anything which happens with commercial crew over and above the sort of basic US government market is kind of viewed as upside. And that's a stark contrast to, I think, where we were a decade or so ago. We were basing our business plans on the idea that there were going to be, as I said, 20, 30 launches a year. So, maybe the moth's getting smarter. Maybe the flame is burning a little bit less brightly. I also think that the balance between risk and reward today, between the government and industry, is actually a lot more rational than it was. If you go back to the ELV program, the government put up about 20% of the cost. Industry put up the rest. Turned out to be a great deal for the government. We developed 2 families of launch vehicles that have turned out, I think, to be incredibly effective. We have a 100% success rate in both of those systems. And the government got that for about $1 billion. It's a pretty good deal. It turned out to be less of a great deal for industry. Let's just leave it at that. But if you look at it today, so between COTS, let's look at the COTS program because I think that's kind of instructive. The COTS CRS program, government's putting up more than 50% by any estimates, right? So I mean, that's a pretty reasonable investment. And as I said, you know, we've got guaranteed launches for CRS. I think this is a very attractive program that I think contrast in some ways with the situation we had at the turn of the century where there were, in theory, guaranteed government launches, but those launches didn't show up for almost a decade. Most of the spacecraft were really late. And the early part of this decade was a very difficult time in the launch industry because these guaranteed launches didn't show up. So not only were we not getting the commercial market, but the government market wasn't there. So it was a very difficult time, as I said. I think, you know, kind of the risk-reward calculation today is a lot more rational. So, you know, from our perspective, this is a pretty reasonable case. And so we're in the launch business, and we've got a pretty effective launch vehicle. So I think, you know, John talked about the development risk. I think we've retired a lot of that risk. There's some minor modifications we've got to make to the system. Other risks in terms of programmatic and business risk for commercial crew are pretty manageable. So on the risk side, it looks good. The upside's good. It's not phenomenal. You know, so maybe we increase our total market with the government market alone by 20%. But what that does is it positions us for the potential market of real commercial crew, right? And I think many of us in this room believe that there really is a passenger travel, spaceflight participant, whatever you want to call it, market out there. But we don't know, right? We're not going to know until somebody goes out there and proves it. And what this contract enables us to do is to build the capabilities to support that market while we're supporting government needs. And then everything that happens on the commercial side is upside. And the upside potential is really significant. So for us, this is a good thing. This is a really great thing. Sometimes maybe too good. I mean, I'm spending an awful lot of my time under the desk writing proposals for both my customers here. We're all very busy right now. But I think that I think that we've got a good position in this market. I think there's some important things that we bring to the market that I think offer discriminators. And I think John characterized that really nicely. But I mean, first of all, when you talk about launching crew, you got to start with safety, right? It's fundamentally, when you're launching humans, about safety. Now, the folks in this room, folks on this panel, have been working really hard on getting commercial crew alive, and I think we've got a sustainable program. We've got some momentum. But if we have a failure early on in this program, it's going to be very difficult. You know, we'll be down for a long time. So I think that you can't overstate the importance of safety. Now, we think about mission success at one launch at a time, but as John noted, we've had a lot of mission success, 100% success with both of our systems. And it's not just about the system, you know, it's really about the whole team. So the Atlas team has been flying a record of now about over 100 missions that we've had success if you go back to some of the previous Atlas systems. And I think that's really kind of an important point, that if you look at the history, going back a little further, you know, when we first started this, you'll see, if you look at launch vehicles, you see that typically we get 10 launches and then there's a failure, maybe 15, maybe 20, and there's a failure. And there's this, you know, kind of curve where you get successes and failures, more like a sawtooth almost. We've got 100 missions now. We think we've got the recipe, you know. It's taken a long time to get there, but it's been 20 years, and that's pretty impressive, and it's really important when you start talking about this stuff. That's a piece of it. I think the second piece of it is credibility. You know, we're operating in a new world. This is a very different relationship between government and industry, and it really requires a lot more trust. So I think bringing credibility in terms of schedule, in terms of technical transparency, in terms of contractual credibility, cost credibility, is really important to being successful in this business. You know, we've got, I think, a very rich and important history working together with the NASA Launch Services Program. There's a real partnership there. And if we actually look at all of the different sort of oversight, insight regimes, we actually think that LSP has it about right. There's kind of a sweet spot. You know, we learned in Titan that if you do too much oversight, there tends to be a little bit perhaps relaxation, that you believe that somebody is going to catch anything that's wrong. We think that LSP has got it about right. And I know Wayne has done some work in this area suggesting that that's a good model to start from. And so that's where we're headed with commercial crew. It's a good model, but it really requires a level of transparency that is for some of us very difficult to achieve, and that's very important for us. The contractual aspect is important. We're entering into fixed price contracts, but there's always contractual instability. ULA is very proud of the fact that we are the first major contract that has had all of our business systems certified. It's a big deal. So we feel like when we give you a basis of estimate, when we give you numbers, we're going to stand behind those. And then finally, schedule credibility. It is critical that when you need astronauts up there, they get there on time. And we've got industry-leading launch reliability. We average about 9 days, which may not sound that great, but it's a lot better than most of the industry if you look globally. So we think these are important things to bring to the table. And finally, let me touch on value. So John mentioned, price as a discriminator. That's not what launch value is really about more than that. So if you just look at it in terms of there's price, now what's the real cost of launch? Well, it's more than just that. If you've got a reliability factor, and let's say we think we're at about 99% reliability. Our demonstrated reliability is 100%, let's call it 99%. And let's say you're at the industry average of sort of 94, 95% reliability. What's that mean in terms of dollars? Well, if you're flying, let's say, $1 billion payload, that's about $50 million. Okay, so that's something to think about. You can't really calculate the value of losing astronauts. You can't calculate the value of a space program that's going to be down, for months, if not years, due to a failure. So that's an important piece of it. And let's look at launch delays, right? For some systems, if you've got the standing army supporting a spacecraft, that can run into $10 million a month. So if you've got launch delays, that adds to what the real cost at the end of the day is. And so if you combine these things, we actually think we bring a lot of value to the table. So that's why we're here. As I said, we've been supporting this program for a very long time. We were here, I think, at the very beginning. We continue to support it. I think from a risk-reward standpoint, Wayne, we're in much better shape than we were historically. So let's get on with it.
Thanks, Andy. So we come to the question and answer part, and we've got a number of questions that were formulated before during some of the teleconferences, and a number of questions from the audience. One of the questions I'd like to start off with is looking at the commercial crew program, the COTS program, the space policy, I think, point for all these programs is to get transportation, be it people or cargo, to low Earth orbit reliably, but at a much lower cost point than has previously been the case. That's kind of the overarching space policy goal. Once that occurs, perhaps an industry with other tenants than the government will provide the business return on investment as well. But to meet that cost point, revolutionary lean teams have had to work on these projects for the different folks. And I'm going to ask each of the panelists in turn how their organization has responded to this challenge to meet this reliability plus leanness, low cost operation that is the point of both these programs. And I'll pose it in a little bit different way to each one of the panel members, and I'll start with John Mulholland. John, you come from Boeing. Boeing is a long-time traditional aerospace company, done a lot of commercial work in airlines, done a lot of government contracting. How have you in the CST 100 program adopted lean cost control methods and at the same time ensured reliability of your product?
Yeah, absolutely. And that is one of the benefits we get from the Boeing company is to be able to leverage that experience base on development programs that have been successful, and also, and even probably more importantly, those that have stumbled. And there's a couple key aspects, and and I harped on it earlier, is performance to plan, right? And eliminating traveled work, no matter what the development platform is, that just is crucial to making sure.
So some of our people may not be familiar with the term traveled work. Would you take just a second to describe?
I'm sorry. Yeah, absolutely. So as you head to, for instance, critical design review, there are some key fundamental aspects of what a successful critical design review is. But in essence, at a critical design review, you need to make sure that your design will satisfy all of the design requirements, and to be able to produce the artifacts that show that, either analytical or test. As you push some of that completion into the next phase or beyond critical design review, where the focus now is on verification and validation, qualification testing, you significantly increase the technical risk, which is going to drive cost and schedule every time. So a huge focus on making sure you perform to plan. And one of the real benefits that we've been able to get in this commercial crew program that has really helped us lean out and produce a cost-effective product is decision velocity. And in the commercial crew program and NASA's involvement, what typically on a typical development program might take several months to get a technical decision, we can get in days. And you just are focused on making sure you have the right analysis and the right team together in one meeting and make the decision and move on. And I think that's been incredibly important. But why are we able to do it? And I think why we were able to do it is NASA has essentially created the infrastructure and with the Space Shuttle program developed the expertise so that low Earth orbit is not the same challenge that it used to be, and which is why NASA is now looking out for beyond low Earth orbit exploration.
Outstanding. Okay, thanks. And Mike, Orbital, I keep calling it Orbital Sciences. It's Orbital Corporation now. Has been noted as an innovative company that has developed a lot of satellites and a number of different small launch vehicles. But we're 20 some odd years down the road now, and you have a little a maturity in the organization. How are you meeting the challenge? How is Orbital addressing the challenge of maintaining a low cost but highly reliable cargo capability?
I'll say a couple things. My background is more on the defense side of things, and one of my programs from previous history, the Orbital Boost Vehicle program, actually is a supplier to Boeing. We produced over 50 interceptor boosters, and in that process, I think Orbital in general grew up a little bit in terms of what it really takes to lean out a process and drive down to really, what it takes to strictly add value over both in what we do and what our suppliers do. I think it's an attention to detail, and a relentless driving of defects out of your processes and out of your factories that allows you to perform to plan, as John says, and continue to hit an operational rhythm, and that's what really allows you to keep your costs down. We're obviously bringing a lot of those lessons learned both from there and on our satellite side, where we've done multiple iterations of a similar design for various customers. I think another piece of it, another element of it is just the approach with the customer, with NASA, and rather than a typical government procurement where they flow down a bunch of requirements, some of them from the contractor's perspective of questionable value, they're working with us and really collaborating to come up with the most efficient and making sure that everything we're doing is ultimately adding value to both the product, keeping it affordable and keeping it available when they need it.
Very good. Brew, the Sierra Nevada company's been around for quite a while. They've been making great satellites. They do aircraft modification and outfitting, a number of different things. This is their first foray into a human-rated orbital spacecraft. So I know this may be a little bit, you've only been with the company a few months, but can you address how Sierra Nevada is building in expertise to augment their core capabilities to do the Dream Chase.
Sure, Wayne, thanks. Yeah, and that's a great segue because Sierra does have a long history of aircraft development modifications. We just recently flight tested a WB-57 for NASA. So that was something that just rolled off of it was a 2-year project, finished had a schedule, and we flight tested successfully just a few months ago. So
First time that plane had flown in 40-some odd
41 years.
Yeah.
41 years. So we'd like to leverage off of our skills in that area, but also leverage off of skills in other areas. Sierra Nevada has a very lean team. John, you mentioned before that your team, John, is about 350 people. Ours is about 135 people. But that was that team of 135 people that was responsible for that Dream Chaser you saw that's getting ready to perform a drop test soon. But it wasn't just those 135 people. Our team also includes some very talented teammates who've been in this industry a long time. So we're bringing those together, folks like Lockheed, folks like Draper, Aerojet. So we have a lot of teammates that aren't that don't necessarily wear the Sierra Nevada badge. So we have a lean team to make those decisions quickly, as you alluded to, John. The decisions that can be made, that traditionally we've been used to seeing being made over months, as you mentioned, and now being made in hours or days. So we have that lean core team, but we're also leveraging off of a lot of experience that's been around the industry for 50+ years. So, and we also have a philosophy at Sierra Nevada. We like to build a little and then test a little. And then we've seen that through all the commercial crew development cycles. In CCDev 1, we built a primary structure and tested it in that very first phase. And so we built it a little bit, tested it. Now we're building an actual vehicle. We're going to test it. We've tested it already on runway tests and captive carries, and we're going to be testing here in the next couple of weeks with a drop test. So bite off small chunks at a time and not trying to get ahead of ourselves, but build a little, test a little, and leverage a lot of experience in our industry with a core lean team at Sierra.
Outstanding. And Andy, United Launch Alliance has this amazing success record. And the launch vehicles are mature and all that's great, but the cost pressure on this commercial crew program is intense. So how is United Launch Alliance working to help incorporate new management techniques or what have you to meet that cost pressure?
So as long as there have been launches, as long as there has been space, the biggest problem with space has been the cost of launch. Over the years, there have been a number of miracle cures. We're going to have single-staged orbit, two-staged orbit, and now we're going to have a completely different recipe, and that's going to fundamentally change it. That's not what we're really doing, but I will tell you a couple of things. That, first of all, if you go back and look at the legacy systems that preceded Atlas V and Delta IV, and you compare them to the cost of launching, let's say, a specified manifest to what it would cost to do it with Atlas V and Delta IV, it's about a 35% reduction. And these aren't our figures. These are DoD's figures they came up with. So we've done a lot already just through the design of our systems to bring costs down. That's not enough. We've got to do a lot more. So I'll tell you that since we formed ULA, we've developed a measure of efficiency we call unit cost, equivalent unit cost, and it's basically the cost of our labor to launch a unit. So it kind of cuts out the suppliers, which is another issue. But we brought that cost down by about 25% since we stood up ULA. We're planning to bring that down, in fact, our total cost by another 30% over the next 5 years. So we're doing the blocking and tackling that it takes to do it. And it's not about doing anything fundamentally new. It's about lean processes. It's about getting cycle times down. We brought our launch cycle time down to about a little over 30 days on pad, between launches on a single pad. And that's fundamentally how you get cost out in a fixed cost business. That's what we're in, a fixed cost business. I think it's also worth noting acquisition approaches. We are in the process of negotiating a block buy with the Air Force, as many of you know, and that's going to bring our costs down pretty significantly. We're able to go out to our suppliers and basically buy about 5 years of hardware. That's going to make a huge difference. We had been almost buying it on an annual basis. And our suppliers have the same issue, right? They've got fixed costs to handle as well. I'd also point out that I think the acquisition approach here is one that's really useful, and I'll go back to EELV. In many ways, the Space Act agreement that we used at the front end of this, of commercial crew and commercial cargo, mirrored what we had done with EELV. We had what was called an OTA, Other Transactional Authority, for EELV. It looks a lot like a Space Act. But as I said earlier, we were able to develop these systems very efficiently, 4 years from ATP to first launches. As I said, the government spent about $1 billion on it. So acquisition approaches can really make a difference, and I think that's another piece of it. But fundamentally, you know, as I said, we've got a recipe that works. We're not going to do anything that fundamentally changes that recipe.
Okay. Time is passing here. I'm having too much fun. I hope you're getting something out of this. You know, we all love to watch Smoke and Fire and talk about rocket launches, but you know, contracting and management techniques are what make the program go forward. I wanted to ask this question from the room. Most of the folks in this room and on the panel would say safety is paramount. There's a smaller contingent that says we are too risk averse. Would you please comment on this? Anybody want to take on that question?
I already did, but I'll repeat what I said.
Yeah.
That I think in a program like Commercial Crew, we've all worked very, very hard to make this thing a reality. If we have a failure early on in the program, a stumble is going to make life very difficult for us. It's very different than if it was a mature program. So I think that's something we need to pay attention to. And like any program, Commercial Crew could have issues with infant mortality.
Anybody else?
Yeah, I don't think you could characterize or should characterize NASA as the primary customer of being too risk adverse. You know, they've been very forward thinking, I think, in their approach to cargo and crew. Cargo is just central to the sustainability of space station. And so NASA has stepped forward and put that, their critical path in the hands of two suppliers. So that is, some would say, somewhat risky, that the government kind of turned over the reins to that. Crew is just at a different level, right? Cargo is, although high value and very important, it's at a different level than crew. And so NASA's stepping forward and is going to be willing to put crew transportation in the hands of the contractors and take one step back. So fundamentally, that is not risk adverse. That is really leaning forward. Now they just have to figure out what the right balance is for crew and what the tolerance level is going to be for mission assurance in that environment. But you know, that's just going to develop.
Super. Well, great answers, and I wish we could go forward, but the clock says we're out of time here, and I just want to remind everyone that we are talking about risk and reward being the intersection that leads to innovation, and I think everybody up here represents a team that's very innovative and working very hard to push forward this whole enterprise of getting into space more rapidly, more frequently, and at lower cost. And I want to thank the panel for being here, and we'll turn it back over to Mike.